Welcome to my program. I'm Dinesh Vijayawardhanan. Today we're going to continue from my last topic, which is wave and its characteristics. What are the mechanical waves? Today we're going to actually discuss further what are the physical quantities associated with waves. So the topic we today discuss is physical quantities associated with waves. So basically, when you consider the physical quantities associated with waves, there are the major parameters that we need to consider is the displacement. First one is displacement, because without a displacement there wouldn't be a wave, because wave is a motion where the particles displacement of the medium. And the second parameter would be time. So displacement we usually put S symbol, time we put simple T for that. So now let us draw a wave with displacement over time. So, and if we draw the wave, just a generic wave like this, and basically we have to analyze how the wave behaves over a period of time. So it starts from t, where the t is 0, so we will call it t0, and then it reaches the maximum displacement. So that's the maximum displacement, S max, at this point, which is t1, and then it reaches the 0 point, displacement 0 again at t2, and then it goes in the negative direction, which is t3, that point, and it reaches back to the 0 point, which is t4. So that's basically how the wave behaves over a period of time. So basically, theoretically, when we reach from t0 to t4, we call it a one period. So from here to here we call a one period, because we draw this wave on a displacement time graph. So this can be called period. If you draw a normal wave without these parameters, it will be a wavelength. But in this case, because it's a time axis, it's a period. So if you explain the period more in detail, we put a capital T for period. So in this case, the period would be the final time is t4 and minus the initial time, which is t0. So that would be the period, which could be seconds or which could be hours, anything. It won't be hours, it would be in seconds or milliseconds, because sound waves or water waves travel so fast, so it won't take hours to travel in a one period. So that's basically what physical quantities associated with wave. Now if you discuss this further, now last time we discussed what is a crest, which is the the waves, the particles of the medium, maximum from its initial position, maximum distance, so that if it is in positive direction, this is crest. If the particle or the medium moves maximum in negative direction, it's called trough, which we discussed last time. Now, the next parameter we need to discuss is with this is the third parameter we need to discuss is the wavelength. Now let's draw a normal wave like that. Okay, and in this case again this is displacement S. This won't be time in this case. This will be the distance from the source. So that is the distance from the source. So this is the starting position, that's the source. This is where the actual wave starts, the vibration starts, and then keep moving in this direction with the velocity v. And in this graph, now in previous graph we took we said that this the distance, this particular section of the wave is basically a one cycle. So because initial graph we took, that's the t0 position and this is the t4 position, and the difference between those two is one wave, and then it starts back again with the same motion and it keep going on. This is another cycle. So this is a one cycle, and it's another cycle, that's another cycle. So in this one cycle, because this axis is distance from the source, we can call this particular section of the wave is a wavelength. So this is the actual wave. If you measure the distance between here to here, the zero initial position, final initial position, so zero initial position, and then when it reaches the T4, which is going maximum and going negative maximum and coming back to zero again, that is a wavelength, which we call in physics terms lambda. And there's another parameter that we need to understand is when you consider a wave like this particular distance, which we call the maximum displacement, we call it amplitude. That's called amplitude. And then we have to also think how these terms relate to each other. So basically in physics we have a formula called V equals F lambda. So as we know, the lambda is the wavelength, V is the velocity. Velocity usually is a measurement of displacement over a period of time. So the velocity usually displacement divided by the time. So it could be usually meters, units, meters divided by the time seconds. That's the SI unit for velocity, meters per second. And then the F, which we haven't discussed in this case, F is the frequency. Frequency, I think in my first topic we talked about what the frequency is. Frequency is the speed of the wave, which is how many cycles that happens in a period of time. So if, for example, if this is 1 second, and let's say if this is 1 second, and within a 1 second we have one cycle from here to here, or you can call, if this is half a second, and it's one cycle in that half a second. So frequency would be the amount of cycles within a certain period of time. So amount of cycles, so cycles per time. So cycles is one cycle and time is half a second. So the final answer, frequency in this case, would be 1 divided by 0.5, 0.05, 0.5, which is 2. So the frequency in this case is 2. There's a unit for it, is called hertz, which is the hertz is the person who found this actual parameter. So they honor the actual scientist by putting the name, the unit on its initials. So that's basically what you need to learn on what are the theories, physical quantities associated with the waves. We will discuss this further in my next topic. Thank you for listening.